Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we're going to introduce the chapter, A Digression to Real Three-Dimensional Vector Spaces. So in this topic, we're just simply going to describe this digression to three-dimensional real vector spaces, and we're going to give an overview of the topics that are to be covered. Now, this is a course on generalized vector spaces. However, for some reason, not sure why, humans have this particular interest in R3. We are going to focus in this topic on lines and planes. Now, common applications include navigation, video games, 3D printing, architecture, and other aspects of engineering in general. R3 may also be referred to as 3D space or just 3 space. In this topic, we're going to be looking at the vector representation of a line. We'll then look at a line passing through 2 points, the vector representation of a plane, the equation of a plane, what you saw in secondary school, the cross product, something that's completely unapplicable to any other dimension, the equation of a line, and the plane containing 3 points. We call this a diversion as it contains ideas that are really not applicable to linear algebra in general. For example, it introduces the cross product, which some of you have already seen. This is essentially an algorithm for finding a third vector that is orthogonal to 2 given vectors. Of course, this is only going to be possible in R3. For this chapter, it's useful to recall that the canonical basis will be represented by I cap, J cap, and K cap. Because after all, there's only 3 dimensions, and this is actually quite often used in fields such as physics. In general, if we had an n-dimensional vector space, we represent the canonical basis vectors as E sub 1 cap through E sub n cap, but for the special case of 3 dimensions, these will be the canonical basis vectors. Consequently, every single vector in R3 is a linear combination of these vectors, and any linear combination of these vectors produces a 3-dimensional vector. Recall that the cap on a finite dimensional vector indicates that these are unit vectors. That is, their 2 norm is equal to 1. So, following this short topic, you now understand the topics that are to be covered in this chapter, and you know that most of the material is going to focus on lines and planes in 3 space. Here are the references, acknowledgements, the colophon, and a disclaimer. Cheers!